Let's talk about the latest MotoGP Aero development and its impact on racing. If you want to know the basic function of MotoGP aerodynamics and what each device does, check out my earlier videos on the topic. Essentially, we can cluster aero devices in MotoGP in three categories: front wings, rear wings, and ground effect devices. Initially, front wings came up to produce some downforce on the front wheel while accelerating out of the corner, to keep the wheel on the ground for longer, which allows to apply more torque, so the rider can accelerate faster. Also, these front wings help to improve braking performance with the higher load on the front wheel. But the special thing about bike aerodynamics is that it leans into a corner, which changes everything. Now, these downforce producing wings create more side force than downforce in a corner. So teams started angling them. The inboard side's exit will be blocked by the rider in the corner, so only the outboard side is active. But a disadvantage of angling these wings is that they produce less downforce in a straight line. To increase downforce, manufacturers either use a cascade of two elements or position two wings above each other. Here, the disadvantage is that the pressure areas between both wings cancel each other out, so a larger gap, less high pressure on the lower element, and a more aggressive suction side on the upper element can help to create more resulting force. In order to avoid tip vortices and induce drag, teams design a rollover between these wings. The higher blockage next to the engine's air intake helps to increase intake pressure, which results in more power. But not ideal with front wings in a corner is the high position. So the lever arm pushes the bike down instead of loading up the tire. So teams concentrated on straighter front wings for a straight line advantage under acceleration and braking, and use other devices for downforce in a corner. For even more downforce, Ducati created a large span double wing either side of the fork. To further increase front downforce, teams use another two wings at the sides of the bodywork. Again, they connect both to have a better transition between the pressure areas and avoid induced drag. This vertical part then becomes very interesting because it gets very close to the ground in a corner. And if they angle it slightly, it's a wing element parallel to the ground, which means ground effect and lots of downforce. At the rear of the bike, we have basically two different rear wing designs. One is a horizontal wing, which again, like the front wings, helps with more downforce in a straight line, under acceleration and braking. And the other angled design only reaches the perfect angle in a corner. So such bikes are a bit more nervous in straight line braking, but you can carry more speed into a corner and brake more at the rear while turning in. But the problem here again is the high location and hence the lever arm to the rear wheel in a corner. So it would be much better to have downforce producing parts in a lower position in a corner. Which brings us to ground effect devices. If a curved surface is close to the ground, the downforce increases dramatically. And so, teams are working with side diffusers which are close to the ground in a corner. Also here are two basic designs. The first one is a diffuser channel, so a large intake and a curved guide downwards, which catches the air in a corner and guides it underneath the bike in a corner. To make this work, you need a very clean and round underside of the bike, as this will become the diffuser in a corner. Advantage of this design is that you only have this vent and the rest of the bodywork is pretty slim. You can still have air outlets in a lower position, and you can use the downwash in a straight line to control the tire wake. The other side diffuser design is changing the whole side of the bodywork into one large diffuser surface. Large surface means more downforce, but the compromises for the rest of the bike are relatively big. With such a design, your bike gets a lot wider. The angles need to work exactly with the lean angles of your riders, and there shouldn't be any holes in the surface, which pushes all cooling outlets up. Depending on which slip angles you design your bike for, you assume that air is traveling between your wheels in a corner. For higher slip angles at the rear, you could assume that air is just traveling along the sides of the bike, which then results in such a design. The edge, which would destroy the diffuser flow on other designs, can help to seal the diffuser better to the ground in a corner. And as you can see, it allows for a center diffuser to the rear tire cooling wing as well. Honda now also jumped on the Aero train and uses a large diffuser duct at the side, but unfortunately they still have a large hole in here for the exhaust. So such a side diffuser is a huge surface in the middle of the bike which creates downforce. But even better would be a curved surface directly at the unsprung weight of the wheels. And so Ducati played with curved surfaces, which now became a proper two-element cascade close to the ground. So the bike creates downforce in a corner directly at the wheel, and it wouldn't be a surprise to see these things at the rear wheel soon. So these are the basic elements, and every manufacturer is now playing with these devices. But what does that for racing? It means that MotoGP bikes nowadays have such a high performance, partly because of aerodynamics, that if they run in dirty air, they lose lots of this performance. So exactly what we predicted before happened now in the 2023 season. Riders have to look for clean air when following another bike to have maximum downforce, but then they are not on the ideal line. And there is another safety issue coming up. Braking performance in the turbulences of another bike is a lot worse. And so it's very easy for the bike behind to crash into the bike in front in the braking zone. And while F1 is reducing aero and working towards a certain concept to improve racing, MotoGP is bringing more and more aero. That is fascinating from a technical point of view, but it's making racing worse, just like F1 before. So what do you think? Is MotoGP going into the right direction? Let me know in the comments below and see you at the next video.